So, VinQ erased last night, so you're going to have to bear with me while I go back and get some information. We'd already talked about the cone is leaking, and so when that cone is leaking, it was dV dt -1 centimeter cubed per minute. We've already done that. The cone has a height of 9 and a diameter of 6. So I had drawn a picture over here, right? My inverted cone. And it has a height of, height of what? Height of 9, diameter 6. Well, that really means radius of 3, right? Because that's what I'm going to need for my formula. Find the rate at which the water level is dropping. So that means we're finding dH dt, and that is when h equals 3. The no, we were given v equals 1/3 pi r squared h. Okay, I don't know why I wrote the find the way I did, but I think that's the way I've done it before these notes. Like, this is what I've always done in the past. Is okay, I'm looking for dH dt when this is this. I've never thought to use the evaluate at. So, okay, and I had started talking about the fact that this volume formula has R and H in it. And this happens several times in homework, doesn't it? But the volume formula has R and H in it. So when I differentiate, I'm going to have possibly RH, dR dt, and dH dt, depending on what cancels out. Well, I'm given dV dt, it's asking dH dt, it gives me an H. Does it ever talk about R? It doesn't ever talk about R. And so in that situation, you have to look for the relationship between R and H, so we can, or a relationship somehow, so that we can get the R to magically disappear, if you will. So with that in mind, if you think about it this way, at some point here, there's a water level here, right? The water is leaking. The water is leaking, that water level is decreasing, right? So this is not a set water level, but at some place there's a water level here. And at some place where that water level is, it's some radius and it's some height. And so the idea here is you can think about similar triangles. So you have a big triangle and a small triangle. The big triangle being what we are given, where the height is 9 and the radius is 3. The small triangle is what we don't know. That's where, this water is leaking out. So at some height and at some radius. Okay. Yes, eventually H is going to be 3, but we don't want to use that right now. So the connection here, if you remember similar triangles from like middle school geometry type, stuff, you can set this up however you want. I don't even remember, did I do 3/9 and R/H yesterday? So if I say 3/9 and R/H, and here's the deal. That's what I did. I could have just as easily done 9/3 and then H/R. I could have done 3/R and 9/H. Lots of combos. But my cross products are 9R equals 3H. If I want R to disappear, I want to solve this so it's R in terms of H. And so R is 1/3 H. That means every place I see R in my original equation, I can replace it with this 1/3 H. So, if my starting formula is V equals 1/3 pi R squared H, before you differentiate, replace it. 1/3 pi, what am I using for R? 1/3 H, quantity squared, times H. Well, 1/3 pi, 1/3 H quantity squared. 1/3 times 1/3 is 1/9 H squared times the H that's already there. We can clean that up and make it a lot neater, because 1/3 times 1/9 is going to be 1/27th. We can put the pi on top of it and say pi over 27 h to the third. So pi over 27 is just a coefficient out front. That's the formula you want to use now to do this problem. Okay? That volume formula does not always represent the volume of a cone, but it does in this case when we have the 9 and the 3. Okay, so differentiate. The derivative of v is 1 dv dt. Derivative of pi over 27 h to the third. 3 out front. What's going to be 3 times pi over 27? Pi over 9, if you will. H to the second times the derivative of h, so dh dt. This is where I don't know, did I fill in the numbers or did I solve it later, or solve it? Looks like I went ahead and filled in the numbers. So dvt is -1. Pi over 9 is pi over 9. H squared. Well, this is when h equals 3. So 3 squared times dh dt. Let's see. 3 squared and 9 will cancel, right? 3 squared and 9 cancel. Can I divide the pi over to the other side? dh dt is -1 divided by pi, depending on the problem. You could leave it as -1 over pi, or you could go the decimal route. Okay, I have both in my notes. Just depends on the situation. I have -1 over pi as an answer, or -0.318. What about a label? Okay, change in height over time. So in this case, it is centimeters per minute. Does that whole sub-it-in thing I left you guys at make a little more sense now? Yeah. Okay, you had some of those in homework where you had to reduce to one variable. So we may have to go back and talk about some of those. Okay? Okay, I think on the lamppost, we're going to talk about A. We're going to look at similar triangles again. Okay, and then I'm probably just going to go forego B, because hopefully I won't regret that decision later. A lamppost is 26 feet above the sidewalk. Andy Great is a 6-foot-tall calculus teacher and is walking away from the lamp at a rate of 4 feet per second. When he is 20 feet away from the lamppost, find each of the following. So how fast is the length of his shadow changing? That is your typical question there. Now, let's see. What do we know? The lamppost is 26 feet above the sidewalk, so that lamppost is 26 feet tall. It's not changing, right? Andy Great. Did you guys catch that? Andy Great.
Andy Great. And the Great.
Huh? I guess we haven't talked about integrals yet, though, and integrating, have we? So thus, no, you're not really catching it. She put that in there, but she kind of put it in there too soon. You guys don't know anything about integrate. Okay, sorry. Okay, so that's what we know. He is walking away from the lamp, right? So he's walking away. So he's walking away. As he's walking away, where's his shadow? His shadow is down here, and his shadow length is also changing, right? So those are the pieces we're looking at. So we're going to label these. I'm going to say X, and I'm going to say Y. So x is the distance from lamppost to Andy. Y is the distance from Andy to the end of his shadow. I guess technically is his shadow getting longer or shorter there the farther he goes? Is it getting longer?
I thought it'd be getting short. No.
Yeah.
Well, the further away he goes, the thing,
I think
the hypotenuse will be getting longer. So
it's longer because if he's right up next to the lamppost, the angle at which the light's going to be hitting him is going to be a steeper incline.
Okay.
And
Now
as
I'm
he gets further, it's going to get.
Okay. I had it backwards in my head, but yeah, if you think about when he's right there next to the lamppost, that's what I needed here. Okay. So we have x and y here, right? Do you guys see big triangle and small triangle? What do we know about the small triangle? It has a left side of 6, and it has a bottom side of y. That's the triangle with Andy, right? We also have a big triangle. Gosh, horribly drawn triangle. With the big triangle, the left side is the lamppost, so it has a height of 26. What's the bottom side of the big triangle? No? It's not x. Huh? No, we don't have any measurements yet. X plus y. It's the whole distance here. Because Andy doesn't end a triangle. The end of his shadow ends a triangle. So this is x plus y. Do you see those triangles? Because you have to see those triangles to make sense of the fact that Andy and his shadow make a triangle. And then the lamppost and the distance from to Andy plus his shadow. Okay. Now, that's our picture to get us started. Let's see. We did the lamppost, we did Andy's height. He's walking away from the lamp at a rate of 4 feet per second. What is that? Derivative of what? No? It's just dx or dy, basically. If he's walking away from the lamp at a rate of 4 feet per second, that is the distance behind him changing. It's the distance between him and the lamp. Because he's going away from the lamp and that distance is lengthening. So dx dt is the 4 feet per second. That is a positive 4 feet per second because his distance is increasing between him and the lamp. If he was walking towards the lamp, and his distance would be decreasing, then we would talk negative. And then ask us when he is 20 feet from the lamppost. So that's when what? When x is 20, right? When he is 20 feet from the lamppost, how fast is his shadow changing? So the length of his shadow is going to be represented by dy dt. Does that make sense there? Because dy dt is going to be the rate of his shadow length. Okay. Now, that's pretty much all the given. I know what I'm looking for. What's the equation that connects all this? No? I'm going to veto Pythagorean theorem because we never once talk about the hypotenuse. And if you throw a hypotenuse in there, like when we threw it in there with the ladder, we knew the length, it was okay. But we don't know a length for it, and we don't have any information about the rate it's changing or anything.
It's plus y divided by y.
equals
26/6.
what are they doing?
So,
You see the similar triangles? And there's not just one right way to set it up, yes? X plus y over y. So big bottom to small bottom, big side to small side, right? Pairing up the pieces. So x plus y over y equals 26/6. I personally would not try and integrate in this form. Okay, yuck. Let's maneuver this around some. This is a fraction equal a fraction, so we can use cross products. So I can say 6 times x plus y is equal to 26 times y, if you will. Can we do some cleaning up there? You can distribute 6x plus 6y equals 26y. You get the y's together. If I subtract 6 over, I'm going to have 6x equals 20y. You can leave it like this if you want. To be honest, they went ahead and made it a y equals. Because eventually we're going to be solving for dy dt, aren't we? So if we go ahead and make this a y equals 6x over 20. So 6/20 is x, 6x divided by 20, or what about 6 over 20 reducing? Could I say 3/10 x? If you want to say 6/20 is x, fine, so be it. Okay. And you could have differentiated several places along the way, but I'm going to differentiate here. Derivative of y is 1 dy dt. Derivative of 3/10 x, 3/10 times the derivative of x with respect to time. So we have dy dt is equal to 3/10 times, what's dx dt? 4. 12/10 6/5 is where my brain went. 6/5 what? Feet per second. Notice we never used x equals 20, did we?
I think there's another one like that in that.
What, that you didn't use something? And what it's just saying is, honestly, any value you use here, this rate's always going to be the same. It's not going to change based on how far away he is or anything like that. Okay. Okay, I think I'm going to stop there. Do you guys want me to do B?
Yeah.
I don't know. I have not really seen anything like B before, to be honest. So, yeah, I think I'm going to skip it.